1 asked us to find the equation for this line, and in order to do that, we had to solve for the slope of the line. And then we wrote the equation as y equals 7/4 x. Now, come down here, problem 1, question 2 continues off of this equation. It says, sketch a new graph of this relationship. I'm going to write that equation down here. We're using the same proportional relationship. Y equals 7/4 divided by x. And of course, my pen tablet doesn't work very well. Let me write that again. There, 7/4 times x. Okay, sketch a new graph of this relationship. Okay, look at the scale. The scale has changed. Previously, the y-axis went from 0 to 28. And the x-axis went from 0 to 22. And the pen tablet makes a mess, doesn't it? Hold on, I'm going to do this again. I tried to write it, but my pen tablet's terrible. Okay, the y-axis goes from 0 to 28, and the x-axis goes from 0 to 22. Now, we're going to graph the same relationship, but the scale has changed on the y-axis from 0 to 210, and on the x-axis from 0 to 160. But we are graphing the same proportional relationship. So how can we do this? Well, just like I showed you in problem number 1, make a table of some points. And then for every given x, calculate what the y should be and graph those coordinates on the scale, on this new scaled graph. So what we have here, here's our x-axis and our y-axis. I'll just write that on there because sometimes students can forget that. I know I used to. So let's try x equals 20. Okay, when x equals 20, what is y? We want 7/4 times 20 because we just pop it into this equation right here. I'll show you the math on the first one, but after that, I want you just to follow along on your paper. 7/4, that's a 4, but my pen tablet's bad, times 20. I'm going to use parentheses instead of the asterisk. Remember that the parentheses mean you're going to multiply something. So this is equal to 7 times 20 divided by 4. 7 times 20 is 140. And then that divided by 4. Now, I'm no genius. I don't want to do that math. I'm going to just pop out my calculator. 140 divided by 4 is 35. 35 is the answer, so I'm going to just erase this and write 35. And you saw how I did it. You can do it on your paper. When x equals 20, y equals 35. Let's plot that point. Oh, beautiful. Fits right there. Okay, next, 40. And I'm just using these points down here. When x equals 40, what is the y going to equal? We'll put it into this equation. It's going to be 7 times 40 divided by 4. And that gives you y equals 70. Go ahead and do the math on your own. Check for my mistakes. And graph that. X equals 40, y equals 70 right here. Let's try x equals 120. Is it even going to be on this graph? I don't know. It might go off the graph. So 120 times 7 divided by 4 equals 210. It's still on the graph. I can plot it. When x equals 120, y equals 210. Now, if I have drawn my points correctly, they all fall on a line. If I have plotted them correctly, I can draw a line through the points. Great, so I know I didn't make a mistake. They all fall on the line. Okay, I did it. It says sketch a new graph of this relationship. So even when you change the scale, the linear equation, or another name is proportional relationship, it still fits on this scale. You have to just make a table of your values and plot the points on there. Our previous graph looks much steeper, but you could change the scale and it could stretch and still have the same slope. For example, what if I change this scale to 10? Oops, let me change to my pencil here. What if we change the scale and this point was 10? Oh, I know something even better. Not 10, 1. Let's say this is 1, 2, 3, 4, 5, 6, 7, 8. And we're going to plot the same relationship. Okay, so when x equals 1, y equals 7/4. Just put that right into our equation. X equals 1, then 1 times 7/4, y equals 7/4. And when x equals 2, then y would be equal to 14 divided by 4. 14 divided by 4 reduces to 3.5. And when x equals, let's go up to 5. When x equals 5, then y equals 35 divided by 4, which is 8.75. Let's plot these points on a different scale. So just ignore this first line here. Ignore that. I'm going to keep the y scale the same, but I changed the scale of the x-axes. 1, 2, 3, 4, 5, 6, 7, 8. So when x equals 1, y equals 7/4. Well, look, 0 to 35, 7/4 is way down here. And when x equals 2, then y equals 3.4. That's still really far down there. Well, maybe it's here, I guess. If we divided that by 10, it'd be something like that. And then for 5, that would be 8.75. I think that would be about about a fourth of the way up. Yeah, about 1/4, because 8 times 4 is 32, and this is almost 9. 9 times 4 is 36. So that's about a fourth. Okay, now do you see what I did? If I changed the x scale, then my line would look like this with the same y scale. So you can stretch out this scale or compress this scale, whatever you want, but you have to go according to the units you put on your scale. According to that scale, what would your line look like? Okay, so question number 2 says sketch a new graph of this relationship. You need a pencil and paper. You need to make this table using the same proportional equation, and then plot your points according to the scale they gave you. And I'll be checking your work. I want to see that your points are plotted according to the scale that they gave you. Okay, get to work on that.